Welcome back, guys. We're going to do trigonometry with calculators, and we're going to do some graphing, okay? So, first of all, let's keep in mind that I've said that on your AP test, you will most likely be doing radians. So, before you take your AP test, you're going to want to make sure that your calculator's in radians. And the way to do that is to go to mode. I'll turn it on first. Go to mode. And as you can see, I'm in radian. If it was dark around the degree, then you would have to move that over. So we are in radians. Okay. Now, so we're going to go sine of 2 equals, and we get 0.09. Now don't forget, we also want to go to 3 decimal places. So when I do that out, I get 0.909. Okay, same thing here. For tangent, we go tangent negative pi, which technically is a radian, divided by 5. And we end up getting negative 0.727. You have to round that 6 up to the 7 because of that 5. And secant. Now, of course, as you guys can see, we don't see secant on the calculator. So remember that secant is 1 over cosine 1.3. So I'm going to go 1 divided by cosine 1.3. And we get 3.738. So be careful of those reciprocals, the other 3 extra trig functions. Okay, now let's go backwards. So we are going to solve for a side, even though we have an angle. Okay, remember we are in radians here. And here I got to double check because usually thetas are in degrees, but we're going to assume that's radians right now. First of all, as you can see, I have the opposite side to the angle, and I'm finding the hypotenuse, which opposite and hypotenuse is sine. So I'm going to set this up as sine of 0.5 equals 5 over x. Okay. Now I'm going to solve for x by using some algebra, and then I'll plug it into my calculator. X is in the denominator, so we have to get that out first. And then we're going to get x by itself by dividing by that sine of 0.5. And then we plug it in our calculator, 5 divided by sine 0.5. And we get the value of 10.429. Okay, so our work. Now, more than likely on an AP test, the only thing they're going to care about is this first step and this last part. Okay, this algebra in between they won't. The thing is, you can't just start with this last part because they want to know where you're getting it from. So you want to have that first. So when you do your work, guys, make sure you show that. Here with theta, we have opposite and we have adjacent. So of course that would be tangent. So we get tangent theta equals 2 over 5. Now, how do we get theta by itself? Because in this case, we're solving for the degree. Well, to get rid of tangent and have theta by itself, you have to do the inverse of tangent. So the way to do the inverse on the calculator is you see it's in blue right there. So I go second tangent 2 divided by 5. And here we go. So we get 0.381. Very good. All right, let's talk about some graphs. So trig functions are periodic. that means that they repeat over and over and over. And that makes sense because we're talking about a circle and then that goes around and around and around. So tangent, though, has a period of pi because every 180 degrees it starts repeating itself. So what you need to keep in mind is from our unit circle that we have the coordinates for 0, pi over 2, pi, and 3 pi over 2. These are the easiest ones to graph. And we should also, though, know that for tangent, because it does every pi, we would want it by our 45, by our pi over 4, okay? So let's look over some graphs. Okay. First of all, let's look at our sine. If you remember, sine at 0 is 0. Sine at pi over 2 is 1. Sine at pi is 0. Sine at pi or 3 pi over 2 is -1. Okay, so see how we have this loop, and what happens is that it keeps going. One of the things you might remember is that, and this actually comes up, so don't think it goes up. Keeps going, sorry. One of the things you might remember is that when we were graphing the sine function last year, we always said that sine starts at 0, okay? Where cosine, well, cosine at 0 is actually the value of 1. So cosine, positive cosine, always started above. And then what happens is that at pi over 2, cosine is 0. At pi, cosine is -1. 3 pi over 2 is 0. And 2 pi, we're back at 1. So as you can see, it's repeating every, let's see. Okay, sorry for that. This is why you don't use pen. Okay, now cosecant. If we remember, cosecant is 1 over sine. So let's talk about this. If sine is 0 at 0, well, 1 over 0 is undefined. So what that does, guys, is it makes it an asymptote. Let's see if I can do this nicely. So anytime that sine is 0, we would have an asymptote. So we have an asymptote at pi, we have an asymptote at 2 pi, so on and so on, okay? Because that does not help. Now, here's the other thing, right? Anytime it's 1, it's still 1, right? So anytime it's -1, it's still -1, right? Because 1 over 1 is 1. 1 over -1 is 1. So we still have these coordinates right here. They still exist in the same spot when we go the reciprocal. Now, how does it differ? Because again, we can't go down and cross the asymptote, remember? What happens is the inverse, it flips it up. So we have a bunch of parabolas. Awesome. So this also goes for secant, right? So that's 1 over cosine. So wherever cosine was 0, we have a y-intercept. Not y-intercept, an asymptote. Sorry, guys. So we have it at pi over 2, 3 pi over 2. Let's see, we have it at negative pi over 2, negative 3 pi over 2. And we end up with the same type of situation where cosine is 1. Well, 1 over 1, sorry, let me clear that out so you guys can see that. Where we have 1 over 1, it's still 1. When we have it at negative 1, well, 1 over negative 1 is still negative 1. So we end up in the same situation. And then again, because we are doing the inverse, it flips the graph. So that means we have our parabolas in between. All right. Okay, so remember this repeats every 2 pi. So now our tangent and our cotangent, we need to talk about that. So one thing that sticks out in the unit circle is that tangent is undefined, right? Because it would be 1 over 0 at pi over 2 and negative pi over 2, okay? Then what happens is at 0, we're at 0. At pi over 4, think of what tangent is at pi over 4 in the unit circle. Well, we would get the square root of 2 over 2 all over the square root of 2 over 2 if you look at your unit circle right now. Well, something over itself is always the value of 1. Now, if we went the other way to negative pi over 4, we would get a negative over positive, so that would give you negative 1. And if you can think about the graph from last year, remember it was this curve. You get very close to the asymptote, but you don't cross. So that happens again here. So at pi, we're at 0, and then we dip down here. We could continue, but our graph doesn't go that far. But for here, we continue. Okay? Now let's talk about cotangent. Cotangent is 1 over tangent. So let's compare it to the graph. Remember, where it's 0 for tangent, it would be an asymptote for cotangent. So it's 0 at 0, and it's 0 at pi. It's 0 at negative pi. And so where it is 1, it's still, or where it is at pi over 4, it's 1 here. Well, if you do the reciprocal of that, you still get 1. Okay. If you do the reciprocal of negative 1, it's still negative 1. So you see how this works, guys? So here it is negative 1. Here it is 1. The asymptote no longer is an asymptote because remember, it was an asymptote because it's 1 over 0. Well, if you do the reciprocal there, that's 0. So where there was an asymptote for tangent, now it's 0 for cotangent. And this, again, it flips, so it goes in the other direction. Great. Now you got your basic graphs for all 6 trig functions. I know we did these 3 last year, but now you've got these. Kind of cool. All right, so I'm going to relate this trig graphing to our transformations, okay? Let's keep in mind that A, right, that's the amplitude. So that tells you how much it's growing from the midline, okay? And then if it's Negative, remember, it flips it. It goes the other way. But that's the amplitude. So remember, that's the height from the midline. The midline is coming from the D. So they call it the vertical shift, but that's really where you're starting your midline if you're relating that to last year. The period, how many times it repeats, comes from B. And then C, which we did not do a lot last year, was a horizontal shift. And if you remember, everything on the inside kind of does the opposite to what you think. So that's why it's opposite C. Okay. Now also keep in mind the period. Before, when we did sine, cosine, we did secant and cosecant. I'm pointing to stuff that you can't see right now, the graphs, right? They repeat every 2 pi. So that's why we have these two being 2 pi. But tangent and cotangent repeat every pi. So when you do period, you want to make sure you get those correct. The other thing I want to point out is that, as you can see, B is found when X, it's 1X. So if we don't have 1X, we have to factor out. Okay, so that would be our first step no matter what. And then don't forget what trig function you're using for where you started. So we're going to practice this with 2 graphs, okay? So what I think you should do is write your information down before you start graphing. So first of all, let's talk about our amplitude. Our amplitude is 5. And then since it's negative, we go in the different direction. We kind of flip. Okay. There is no vertical shift, and there is no horizontal shift or phase shift, but we do have to figure out how much it repeats. So that's our period. So we're doing cosine, so that means it's 2 pi over the absolute value of b, which in this case is 1/2. So when I divide by 1/2, it's the same as multiplying by 2. So what happens is it repeats every 4 pi. Okay, so last year we demonstrated the midline, right? And then we took the amplitude and we went 5 up from it and 5 down from it. Now this is cosine, and cosine we usually started above, but since we have to flip it, it means we're starting below. So we're going to start below, and remember, since we're going every 4 pi, remember every shift is 4 sections away. So here's 4 pi, there's 1 section, 2 section, 3, and 4. So 1 section goes to the midline, second section goes up, back down to midline, and back down. Because here at 4 pi, this one curve, then it starts repeating itself. They want you to see the directions. It says 2 cycles. So of course I can't go to the right, but I can go to the left. So every one I go up a step. And down. So there's 2 cycles of our trig function. All right. What do you notice in B right here that I pointed out before? That t, or x before, had to be 1x. So that means we have to factor out. If you remember, factoring means that we are dividing each piece, okay? So that means we have 2t minus, so if we divided pi over 2 by 2, we would have pi over 4. Okay. All right, so let's talk about what we have here. The amplitude is 1. We don't flip, right? We do have a horizontal shift. Now remember, it's opposite of what it looks like. So that means we're going right pi over 4. Sorry, guys. And then our period, okay, it's sine, so it's 2 pi over the absolute value of b, which in this case is 2. So that means it repeats every pi. All right, so no vertical shifts, so we have our 0 there. We're only going to 1. All right, now, tricky part. Sine starts in the middle, but we have to go over to the right, pi over 4. So let's see, this would be pi over 2, so this one's pi over 4. Okay, if I go 4 sections out, so 1, 2, 3, 4, this is where it repeats. Okay, now I'm going every section I'm moving. Because it's positive sign, I go up, midline, down, midline. And look, we did 1 full period. And then it would start repeating, right? So it wants 2 cycles. So let's go backwards here. So down, midline, up, and midline. Kind of crazy. I know some of you might not be ready for the physical shift, but that's why we practice. That's why we have a bunch of practice for us to do that. Excuse me. All right. This is an identity I need you guys to memorize. Okay, so put this in your notes. Eventually, I'm going to give you guys some note cards that you can start writing things down to memorize. And this is one of them. This is the Pythagorean identity. Look, it kind of looks like the Pythagorean theorem, right? Where we have x squared plus y squared equals 1. Well, remember, cosine is x, sine is y. So isn't it the Pythagorean theorem, just with trig? Now, one of the things I want you to keep in mind is even though you have this identity, within the identity, there's 2 extra ones. And I'm going to show you why. Because I could say that cosine squared x equals 1 minus sine squared x. And then I can say that sine squared x equals 1 minus cosine. So see how I can make 2 extra identities from that one? And by the way, there's actually 6 because we can do, there's another Pythagorean identity with tangent and cotangent, but we'll do that later. Okay, so what we're going to do is actually use the identity here to help us solve. All right, so first of all, what I'm going to do, what I don't like in here is that I have 2 different trig functions. That does not help us solve at all. But what I just showed you is that sine squared is another identity. So what I'm going to do is substitute that in. So I have 2 cosine theta minus, now don't forget parentheses, 1 minus cosine squared theta. Make sure you keep everything in thetas or x's. And then we have equals -2. Hopefully you see our next thing to do is simplify by distributing and putting it in order. So first I'll distribute it, then I'll put it in order. So I have 2 cosine theta minus 1 plus cosine squared theta equals -2. I'm going to move everything to one side, but I'm also going to order it. So we always put our squareds first. So cosine squared theta plus 2 cosine theta. And then we're going to add that 2 over, so plus 1 equals 0. Okay, as a side note, I'm hoping you guys look at this and you're like, wow, it's almost like x squared plus 2x plus 1. Okay, because we can factor that, right? If we factor that, we get x plus 1 times x plus 1. So we're going to do that. But instead of x, we have cosine. So, and I'm also going to put that as squared. So I have cosine theta plus 1 squared equals 0. And now we can start solving. How do you get rid of a square? Take the square root. We get cosine theta plus 1 equals 0. And then subtract cosine theta equals negative 1. This is where we use our unit circle because we want to be in the interval from 0 to 2 pi. And where is the value of cosine? Negative 1? Well, it's at pi, and we're done. Now, of course, I just gave you one example of how you can solve that. And with other ones, make sure you're asking questions, especially after you see the answer, if you're missing one of the radians or not. Could be a plus or minus issue, could be a factoring issue, things like that. But the more we practice, the more we'll get used to it. So enjoy.